Hi, this is Michael King. Welcome back to Time Value Money, Part 2, where we're going to discuss more about present value and future value. This is going to be section 5.3 in the textbook by Booth, Cleary, and Rakita. Okay, remember that we have this formula, which can be used to calculate either the future value or the present value given the other inputs, where K is the periodic interest rate, and we assume there's compounding. N is the number of periods. And notice that K and N are expressed in terms of periods, which could be months, could be quarters, could be years, could be days. It is some period. Your calculator won't know the difference, nor will Excel. So let's look at an example. What is the present value if you receive $1,250 at the end of year 4 and you discount it at 10%? Where discount means to find the present value. So let's start by drawing that timeline of the cash flows. Here we can see our 4 periods. You put your future value of $1,250 at the end of year 4. You have your discount rate of 10%, and plugging it into the formula, you're going to find that the present value is going to be $853.77. Now let's take a moment and think about that. Does that make sense? First, the present value is smaller than the future value. Notice that $853, once you invest it for 1 year at 10%, you're going to earn $85. So you're going to be up to around $935, roughly. The next period, you're going to add another 10% of that, and then another 10% again. So as you can see, it is growing each year, and the total will be worth $1,250 in this example. So let's reverse the formula and calculate a future value. If you invest $100 today for 3 years at 5% per annum, what will be the investment at the end of 3 years? Notice that my timeline has 4 periods, but I'm asking you to calculate the future value at the end of 3 years. You invest $100 today, that's the present value. It grows at 5%, and as we calculated several moments ago, the future value is going to be $115.76. Again, it's just a question of plugging the inputs into this formula, or you could use Excel or a calculator. Okay, so one way that you can solve this problem, you can break it down into 2 parts. And we're going to talk about the second part, which is called the interest factor. And we can have a future value interest factor or a present value interest factor. So let's take a look at this calculating the future value based on the present value. The factor, or the future value factor, is this second part, 1 plus the interest rate raised to the number of periods. Looking at the present value formula where we've just reversed it, the present value factor is 1 divided by 1 plus the interest rate raised to n number of periods. So let's take a look. What is the interest factor using 7% over 5 years? We're going to calculate assuming the future value and then the present value. Well, with the future value, you can see that 1 plus the interest rate of 7% compounded for 5 years would be worth 1.4026. That is the factor. Another way of thinking about this is, what would $1 be worth in 5 years if you earn 7% per year, compounded annually? It's going to be worth $1.40. Okay, so what is the present value? Well, if you receive $1 at the end of 5 years, it is going to be worth only 71 cents today. Put differently, if you start with 71 cents and it grows each year by 7% for 5 years, it will be worth exactly $1 at the end of 5 years. So these factors can be useful because they basically tell you the value of $1 either in the future or the value of $1 in today's. So when using this to calculate future value, you can basically just multiply this factor. Okay, so let's look at the future value factor for $1 invested for 30 years at 5%. what will $1 be worth at the end of 30 years? Plugging it in, we see that it's 1 plus the interest rate raised to the power of 30 periods, and it's going to be worth 4.3219. In other words, $1 will grow to be $4.32. Okay, so if you want to figure out the value of any investment now at the end of 30 years, compounded annually at 5%, you simply have to multiply it by this future value factor of 4.32. So if I had invested $100, for example, well, the amount that I would have at the end will simply be 100 times 4.3219, or $432.19. Notice that this is more than 4 times the original investment, showing the power of compounding. Similarly, you can find what the present value interest factor is for $1 received in the future. What would it be if you discounted to today? So let's do that same calculation, except let's say you have $1 at the end of 30 years, and if you discounted at 5%, what would that $1 be worth today? We see here that it would be 23 cents. In other words, if you invest 23 cents, 23.14 cents to be precise, at 5% per year and hold it for 30 years, it will be exactly $1 at the end of the 30 years. Okay, so now if we have $100 that we receive in the future, all we have to do is multiply that by that present value factor to figure out what it would be worth in today's dollars. So if you have $100 at the end of 30 years, you would need to have $23.14 today to invest in order for it to grow and become exactly $100. So we're just breaking down this formula into 2 parts, the amount that you invest or receive and the factor. So in summary, this time value money formula is really a good building block for finance. You're going to see it very often. It has 4 parts, and as you probably figured out, given 3, you can calculate the 4th. With financial calculators, you will find the buttons on your calculator. You can simply put in 3 and solve for the 4th. Likewise, in Excel, there are built-in functions that can be used for calculating each of these. But you always need to have 3 of them in order to calculate the 4th. Okay. Now, another thing to note is that so far, we have not assumed that you receive any additional payments between the start date, or the present value, and the end date, which is the future value. We're going to relax that assumption in the next set of calculations.